brazing and soldering also is accomplished when the fillers actually are melted. This concept is still fusion, but the difference between welding is the base metal is not melt. So for example, that we are going to um, join two material, which is like aluminum or stainless steel. We have the filler that was added in between of the two part that we're going to join. This filler will be melted. However, stainless steel and aluminum will not melt. So this filler will make a joint through a diffusion bonding with the base metal. So as same goes to soldering process. So normally soldering process is involved in the electronic part for the joining the component to the PCB, the printed circuit board. So definitely component cannot melt, because if not, it cannot do the function. So it will be component pad and also the pad from the PCB. So they will forming a joint. So beside that, we also can join certain like piping using solder. Okay, we'll go one by one. All right. So as mentioned to you just now, that they will require a filler to bond the material, and this filler is melted. It depends on the melting point of the filler. So for brazing, we normally heat above the temperature of filler, normally above the 450, but it's not more than the melting point of the base metal. So you can't actually melt the or give the heat above the melting point of the part that you're going to join, only above the melting point of the filler. So normally filler for brazing, the temperature of the filler almost higher than 450, whereas for soldering, so the filler used we call as solder wire or solder base and solder bar. So this solder has less melting temperature, normally less than 450. So this is actually the reason why we use welding we use brazing instead of brazing. So the first one, if let's say the material has poor weldability, we cannot weld it, but the strength that we require for the joint is not too high, then we can use brazing instead of we go for solid state welding, which is high equipment cost. So the second one, we can actually join this cylinder method, as mentioned to you before. When we join using welding process, you must have the smaller CT. Even though for brazing, you also have to have not much dissimilar between the filler and the base metal. But for welding, the base metal must not so much different, because if not, the heat will be absorbed by the other metal. So this the base metal, let's say A and B. Let's say this one has high thermal conductivity, B has lower thermal conductivity. Definitely, heat will be dissipated away to B. So means that the process of welding having a problem of weldability. But in the case of brazing, even though you can say that it can be joining this similar metal, but you have to have a material that has not much different from the filler material, because filler will be melted and the heat will be absorbed through the base. So you cannot have too high CTE between filler and base metal. But between these two base metals should not be a problem. In terms of heat of welding may damage. So sometimes, as for motherboard or for components that for PCB or for your handphone and for the laptop, so you need to assemble the component, because component has a function so that you can actually melt the part. So that's why you have to go for either brazing or soldering. So we're not actually damaging the part that we're going to join. So geometry for welding normally is not so complex. We can use brazing for the complex design. So that's I mentioned before that the strength is not so high. So whenever you have problem with poor weldability, but if let's say you require very high strength, you cannot use welding. So you have to compensate the properties that you need. Okay. Okay, so basically this is actually the process. So you have to make sure that the filler is melted, and the filler will be uh, distributed through the two work piece or to the base metal through a capillary action. So you must ensure that the cap not too far, the cap not too near, so that the filler can actually flow and forming a joint between the two part that you're going to join. So this is actually the requirement. So no melting of the base metal as mentioned before, only filler will melt. So the filler temperature must greater than 450 because normally the filler that used for brazing is a higher temperature, but must make sure that the heat was actually supplied must less than the base metal that you want to join. If not, the base metal also will be melted. Okay, so this is some of advantage as we have mentioned before. Any metal can be joined, including dissimilar, fast and consistent, permitting high production rate. We can join multiple joint. We can actually do for complex joining, less heat, and we not require more power as for the fusion welding. So we also have less problem with HSZ. So definitely they will not form HSZ as formed by welding process. So this is almost same joining area that are inaccessible while welding process can be braced. So we can actually has a part that cannot be joined can be accessed by brazing because brazing has why mask? Hold on, I saw some. What happened to my mouse? Wait. Can we use the same material for both filler and workpiece? No, we can use the same base metal, but the materials for filler there is a certain material that can suitable for different for certain material. I'll show you later. But we can brace two different material, but the filler is normally will have to couple with the material that we use because definitely you need to form a intermetallic compound otherwise or solid solution otherwise it cannot form a bond between the base and the filler. Okay, limitation so that as compared to welding, so the joint is actually very less as compared to welding. So high service temperature, if let's say you are brazing the material but and then you use at high temperature, so definitely the filler will be melted, so you cannot use the at temperature above the melting point of your filler. Once you have joined the part, you cannot use in the service that require high temperature than your filler. If let's say the filler will be melt, definitely there will not be the joint is actually is already weakened, right? And what is actually the features that people doesn't like, normally because the color of the filler will have different, so you will not have a mesh color between base and filler. So normally they will actually coated it or do a painting so that they can have a good appearance. But if let's say the parts is actually grounded in the apa dalam tanah, so maksudnya tak ada lah appearance tu jadi problem. So if let's say we use at area that we can actually uh, see it, so some people will actually doesn't like the appearance, so they have to do painting. Okay, so this is some of the application that use brazing, automotive, joining the tubes and pipes, electrical equipment, joining wires and cable, cutting tool, brazing cement carbide into the insert to shanks, jewelries, chemical process, plumbing, pipes and tube, and also repair for the repairing process. But bear in mind for those require not much strength. So you can see here, so this is the filler that will brace the two part, right? So you can see the color is different from the both part. so the appearance is not so nice. So definitely they have to go and paint it or coat it with this coating it. So brace joint, we can actually join either butt joint ataupun lap joint. So they have to have a certain clearance between the two parts so that the filler can be distributed flow the filler tadi senang. So kalau terlalu besar, so dia punya capillary action tadi tak akan effective. So you have to have a certain clearance between the two parts. So as for brazing also, we need to have a cleanliness of your part. Otherwise, you cannot have a wetting of the filler on the surface of the post of your part that you're going to join. So either we use mechanical cleaning or we use chemical cleaning. So either kita guna flux ataupun kita boleh guna um, mechanical like sandblasting to bombard the punya surface to clean the surface. So if let's say you have rough surface, so there will be a very good additions of the filler towards the you punya part. So there are two methods, either you use chemical ataupun you use mechanical. So this is some of the example for butt joints. You can see here, you can brace this simple butt joint. You also can have a scuff joint like this. This is considered as also butt. So, but they have a slanted area of bracing. So this is actually we call as step butt. And this one the same, but the area is big more as compared to this A. So this is some example of butt joint for bracing. So we also can use lap joint for bracing. So this is a simple one as what you use for resistance spot welding. But you can also brace this type of component. We have two component that was actually sandwiched between the cylinder. So you can also brace this type of design, and this is another design that we can actually sandwich it to brace it. So we will go to the type of feeder. Okay, sorry. Before we go to the type the type of filler. So this is some of the example. This is a type of filler, but I will show you in the diagram later. So we can have wire as same as welding. We can have wire to fit the act as a feeder to fit a material to join the two part. We also can have in the root form as a stick as you see in the welding. We can also have a sheet, straight powder, paste, preform part. So this is some of the type of filler that normally used in industry. I will show you that in the next slide, the picture. So this is the base metal, sorry. The base metal is aluminium. So the filler that used is either aluminium and silicon or combined. So if the base metal is nickel and copper, you can use copper. The base metal is copper, you can use copper and phosphorus. If the base is steel, cast iron, you can use copper and zinc. And the base is stainless steel, you can use gold or silver. So this is just some example. So you can see here, this is another example. It's very detailed. So you can see here that this is some of the base metal that used. So this is the example of filler material that can be used. Okay, there are few elements of brazing in order for you to accomplish the brazing process. The first one is the base metal characteristic. So remember that I have showed you about the hardness when you join the cast plate, where you don't do any deformations on the plate. So the plate is actually directly from the cast part. So you can see that the hardness is actually high at the joining area, right? So same goes to the brazing process. So you must ensure that when you do a joining process, so you not actually weaken the base part. Okay, if let's see the base part is made from, it's already full roll. So definitely they will have very high strength that was induced during process of work. So if if the fillers of your material that you use, when you heat it, you will actually going back to the state of annealing as a grain grows. So what happened here, the base material is no longer having the same hardness. So you must be careful when you have this kind of material. So when you select the filler material, ensures that the filler material that you select, the temperature is not so high that can actually um, macam mana nak cakap, that can actually make your structure going to the growth stage. Faham tak? So you remember that you akan ada annealing, you akan ada recovery, recrystallization and grain growth. So ensure that the temperature that select for you to join the filler is not up to the growth stage. So it only can be at the recovery stage, the filler temperature, so that you cannot jeopardize your workpiece. And as mentioned before, the CTE or coefficient thermal coefficient thermal efficiency ataupun tadilah apa, thermal conductivity. So tak boleh terlalu different between the filler and the base metal. So you cannot have too high, because if too high, so definitely the heat will be dissipated away through the part that have the higher CTE. So they will not have a good joint between the filler and your part. So in this case, so there will be a diffusion of your atom go in and out from the joint, because it depends on the solidity of your material. So it can form either intermetallic compound or solid solution compound between the filler and the base metal. So filler metal characteristics, so that's why you should have a filler that can flow easily, then can wet the surface easily. So this can be done by surface preparation. Either you use flux or either you use a mechanical cleaning. You bombard the sand to have a structure of very rough, so that the filler can there is an anchor here, so there will be a joint, a good joint forming between the filler and the base metal. So joint design or clearance, you must have a very good joint design and clearance, so that the capillary action will take place there, where the filler can fill in the area of the clearance. Temperature and time. So you need to select a temperature so that filler is melted, but not too high, so that the base metal also melted together. Rate and source of heating, you have various type of brazing. Either you use torch brazing, you use furnace brazing, or you use induction brazing. It depends on the heat that you require to melt your filler. So this is some of the characteristic of the filler. So it must be compatible with the base metal. So low surface tension, so that it can have a very good wettability. So kalau surface tension too high, so dia akan jadi de-wetting. So it will not wet the surface and forming a joint. High fluidity, so they penetrate through the design that you have been selected. So definitely you should have some strength, so that it can actually forming a certain strength that require for that purpose. If not, if you don't have if the filler doesn't have any strength, so the joint will be broken in the service. So no chemical and physical interact. So tak ada, because of this one, there will be a formations of either solid solution ataupun intermetallic compound. So this is about the brazing flux. So we only concentrate on the flux. We are not actually talking about the mechanical, but mechanical also can be used to clean the surface. So flux definitely they will clean the surface, ensures that there is no outside layer left, dissolve all the outside. So definitely they should have dia punya characteristic low melting temperature, low viscosity, facilitate welding and protect joint from the protect joint until solidification, so that the filler can actually wetting the surface and forming a very good joint. So this is some of the technique I mentioned before. This is actually the torch and filler. So this is a type of filler. We have a filler rod. We also have ring type. So this is a ring type of filler. So this is the filler rod. So this is actually in the form of foil. So you're putting the foil of filler here. Okay, so this is the methods of brazing. You can use torch brazing. So you akan guna flame. And the heat come from the source of flame. And you directly to the filler, and the filler will melt and forming a joint between the two parts. So this is actually the furnace brazing. So sometimes from materials that very reactive, they have to put in the furnace, and we can actually supply some gases to prevent the oxidation. So this is actually we can use a ring type. So this is another method we use induction brazing. This is resistant brazing. So the electric come from the electrical resistance. So this is the deep brazing. So you dip your part in the molten salt or molten metal bars. So the last one is the infrared brazing. So this is very high intensity infrared used to heat your part. So this is some of the brazing method that used in the industry. This is a microstructure of brazing that we join metal to non-metal. So this is the feeder. We can actually join diamond to steel substrate. So this is the non-metal to metal. We can also use to join metal to metal. In this case, we are using aluminium and stainless steel. So you can see that there will be a forming of the intermetallic compound between the braze and stainless steel, so that they will have a good joint between braze ataupun filler and the substrate or base metal. All right. So any question on brazing? Nanti you have homework. Ada question tak brazing? No. Okay. If no question, we move to soldering. So soldering same as brazing, but it use we not name it as filler. Kita panggil dia solder paste ataupun solder wire ataupun solder bar. We call it solder. So it is different form. Either paste, wire. They also have in preform. So the temperature of solder is less than the temperature of brazing filler. So normally will be less than 450. So same as brazing, the part that going to be joined not melted at all, only the solder will be melt. So this is some of advantages and disadvantages of the solder. So lower energy than brazing, and also for the fusion or for the fusion welding. So you can use variety of heating methods. For example, later we have reflow, we have soldering, we also have hand soldering. So good electrical and thermal conductivity that normally it's used in the electronic to form a joint, and also metallurgical bonding between the component and the PCB pad. And it's easily to repair and rework. We can actually rework the solder if let's say we found a defect. So disadvantage, it has a very low strength. So sometimes nowadays they are reinforced with the some of the ceramics particle to enhance the strength, and as well to increase the temperature of the solder, so that you can use at high temperature, possibly wicking or melting point. So maksudnya kalau kita guna pada tempat yang terlalu panas, so we can actually have the joining problem. So that's why, so when you use your PC or when you use your laptop, so sometimes aging will take place because you are heat it and cool it, heat it and cool it, become an aging process. So when aging process take place, so there will be a higher amount of intermetallic compound that will be formed in your joining. So this remember that intermetallic compound is brittle. So after a certain time, so they will have a brittle join between your solder and your component. So then your laptop and your PC will have a problem on the connection, but we can still rework that. Okay, last time, Stanham and Plumber are the alloy for solder that used long time back, because the combination of these Stanham and Plumber have very low melting point, which is 183. So you can see this phase diagram. So normally they will select this composition because this composition has lower melting point. You can see here that the melting point is around probably 183 tadi kan, 183. So you have composition around 6, sometimes people call 62 60 60 for 60 40 ataupun 37 63. So this composition, so it's directly from liquid to solid, so it doesn't have a mushy zone. When you have a mushy zone, so you're allowed a lot of shrinkage, because kalau sini you akan dapat mushy zone sebab you reduce daripada liquid, and then after that the first solid will be forming, and some of your material still in the liquid, so you'll be a shrinkage. So that's why they are selecting this composition, and because of the low melting point, so they select this composition. So this is long time used in the industry, and when the European Union is actually prohibited the use of hazardous material, restrictions of hazardous substances. So this is actually come up by the European Union. So those electronic material that are going to ship to Europe must actually free from all these hazardous substance, and this has been incorporated in the industry of electronic industry. So you can see here that lead, mercury, cadmium, hexavalent chromium, polybrominated biphenyls, and polybrominated diphenyls as ethers. So all this actually was restricted. So then the manufacturers have developed a new source of solder which doesn't have plumber. So what they do, they actually develop stannum copper, but stannum copper ethactic is at stannum 0.7 copper. Mana dia? Here, right? Here, somewhere here. So, but you can see here that the temperature is 2 to 7, meaning that the temperature is higher as compared to temperature of stannum plumbum. So what happened here? So all the component that was used for that was used before, that using solder base of stannum and plumbum, have to change dia punya apa lagi? Ability to retain the heat, because if you use the same component, so it might melt, right? So that definitely all the developers of the component also have to change, so they need to fine tune your punya component to extend the temperature. So this is still high, and people are actually do some research, and they using stannum argentum, but bear in mind silver is actually very expensive. But you can see here that silver has reducing the ethactic temperature, so it become 2 to 1, somewhere here, right? 2 to 1. So temperature of solder has been reduced from 2 to 7 to 1, but people are still doing the research, and they can actually come up with this combination where the ethactic temperature is reduced to 217. So it's really reducing as compared to SNCU and SNAG. So they combine these three compositions, so they get this three composition, which is stannum, 3 argentum, 3 silver plus 0.5 copper, and also stannum 4 silver, 0.5 copper, and stannum 3.5 silver, and 0.7 copper. So this is the common SAC. This is the common SAC 305 is a common solder that used in the industry. But but they also can actually manipulate some others element to incorporate inside the this solder to reduce the melting point, or to actually inducing some nucleations so that the beta phase become very fine. So there are a lot of research are doing today to come out a new compositions of solder. So this is some of the element that was used. For example, here bismuth, they lower the temperature, but it has some toxic concern with the animal. But we can also use indium, but indium are very expensive. So there are certain elements that cannot be used in the solder. So they are doing research thoroughly to incorporate some of element that can actually enhance the mechanical, or by blocking, or by restricting the growth of intermetallic, or by um, reducing the size of beta SN to get the to give the strength of the solder. So there are many kind of research are doing on this solder composition. So I just list all these element. Maybe you can actually can refer this if let's say you need this information. All right, so this the intermetallic compound that will be forming. So this one is Cu6SN5 for SN plumbum. Maksudnya ini adalah untuk yang solder phase yang dulu yang menggunakan plumbum. But when you use SAC, you will have two solder phase that will form solder phase lah. Two intermetallic compound that will form SCU6SN5 and Ag3SN. So this intermetallic will be forming at the area near to your copper pad, between copper pad and your solder. Okay, so this is actually your copper pad on your PCB. So this is the IMC that form between the, because copper will be diffused in and combined with stannum in your solder become Cu5SN6, right? So, and you also will have Ag3SN that will form at this area. So normally you will want to inhibit the growth of IMC, so that's why they are added many elements, and they also can added ceramic particle to inhibit the growth of the IMC. We don't want the IMC to be grow thicker, so they have a certain amount of IMC are allowable, because if you have thicker IMC, and when the motherboard is used in the service later, so the growth of IMC will be more as compared to you have, if you have a smaller IMC starting, and the growth will become not so fast as compared to the thicker IMCs for starting of your joint. So this is actually another research that they do to inhibit the growth of the IMC. All right, so we don't want IMC, because IMC is, even though it's hard, but it's brittle. So during the process of soldering, so definitely you will have flux. If let's say you use solder paste, so the flux will be combined, will be embedded in the solder paste. If you use solder wire for rework, you have to add the flux on the surface of your pad to facilitate the wetting and reducing the oxide layer on the surface. If you use with soldering, so you have a machine that will spray the flux on the hole, so that it can actually facilitate the soldering process when the part travel to the bus of the solder. So all these require soldering, same as brazing, also same as welding. So there are a few categories of flux. We have no clean flux. So this flux is very mild action. So you don't have to clean it, even though the residue is left. It's not that dangerous. It's not actually dangerous, can actually become a corrosive. So you don't have to clean this type of flux. And we also have the second one, we have rosin flux. So rosin plug have different category. So we have non-activated rosin. So this plug is not activated. So it's a mildly only. So if let's say it's presence on the board, still okay. So the residue is not actually much that leave on the motherboard or the PCB board. So the second one we call as rosin mildly activated. So this has a little bit mild activators. So you need a cleaning on this plug. So the last one is rosin activated. So this one is really great levels of activators. You must actually clean this plug. If you leave the flask, it might corrode your joint. So this is some of the flux that use. We also have organic flux. Organic flux is actually flux that require you to clean it. So you have after the assembly of component, you have to clean in the ultrasonic ataupun dipanggil apa saya lupa dah. Ultrasonic cleaning atau satu lagi apa saya lupa. They have to go and clean it. Okay, so this flour is actually normally water soluble. So they have a weak acid such as citric acid, stearic acid, and so on. So this is actually, I'm not sure whether they are still have this kind of flux that used in electronic, but normally when I work like last time, so all the flux all actually go to no clean flux so that they don't have to wash the PCB after the process of SMT or with soldering at the at the back end or the front end. So they don't have to wash all the boards. So they have actually converted all the organic flux to clean to no clean flux. So this is another, the last one is inorganic. So the most strongest. So it actually need a very clean surface to ensure that there is no residues left. So it actually has a strong acid such as hydrochloric acid, ammonium chloride, zinc chloride. Okay, so you must ensure that when you use this type of flux, you must ensure a very thorough cleaning process so that there is no residues left on the pot, which can cause corrosion later. Okay. So it's the same as brazing. So the flux actually to remove the oxide. It must be molten at soldering temperature, meaning that it must be evaporate. This must be melt and evaporate during the process of soldering. So promote wetting. Be readily replaced by molten during process. So after the flux was evaporate, so the molten can be facilitate the surface and forming a joint. So it will be reducing some residue, either corrosive or non-corrosive, or it must be conduct or non-conductive. So these are some of the methods that you use to solder. You have hand soldering, you have wheel soldering, you also have reflow soldering. So this is the common one that used in the industry. So you have this type. This is actually hand solder for the rework purpose. You have a reflow process. So during the process of reflow, when you heat the solder paste, so the flux will be evaporate first and become and do a function. So then only the solder will be actually wetting the surface. So this is for the wheel soldering. So they have another machine that will be spraying the flux. When the flux go to the heater, so the heater will heat up the flux and the flux will dissolve all the oxides and clean the surface. And when the board travel to the bus that contains the solder, so the surface is already ready for the joining to take place. So the surface is already cleansed and the joint will be formed between the solder and the component. This is some of the example use of the solder in the electronic to join the IC, to join the chip, to join the BGA, all that. So this is another example on the piping. You can also use solder to join your pipe, but you can still use the um, solder with the plumber for the pipe joining. This is some defects that can be actually see in the electronic assembly. We can have insufficient solder. This is for the pin through hole component. You can see that the solder is not sufficient. It should have forming a fillet like this. And this is a cool joint solder, and the solder is not actually melt thoroughly. Maybe there is a contaminants around the joint here. And this is another type of defect, which is bridging. They actually bridging between the two joint. So I think this is the last one, is de-wetting. So the solder is supposed to wet and forming a good joint, but if let's say the surface not clean properly, so there will be a non-wetting, and there will be a open solder. We can see open solder that actually form when this happen. So soldering tak terbentuk antara pad dengan, so there will be a weak connection between this terminal and the pad. Alright. So basically you might work in subcontract manufacturing, which is that's why you have to decide. You can actually apply some concept of what you learn, because I just give a basic explanations on solder here, but you have learned before, because it's a process of metallurgy, because you have learned before when you added alloying in the another metal, you will form solid solution. You will form when the solidity was achieved, you will form another compound, which is intermetallic compound. So you have to see whether that element is actually can form intermetallic compound or only can form solid solution. So you have to check the composition that will be formed later, either intermetallic or only solid solution. So when you have opportunity to work in subcontract manufacturing, which is not actually have their own product, for example, like Jabil, Celestica, Flex, siapa lagi lupa dah, Flexes, Samina, and so on. So they are actually subcontract manufacturers that assemble the part on the PCB. So they will actually involve on the using solder as the fillers, or as the connection for joining the part from to the PCB. So as an engineers for materials, normally you will involve in the as a process engineer to ensure that the um, profile of your pre-flow heating, and also the wheel soldering, and also you can involve in the as a supplier quality engineer to deal with the uh, apa soalan, what is requirement of a good solder joint when soldering is completed. So you will have to ensure, you have to refer to IPC, saya lupa 610 if I'm mistaken. So they will be forming a fillet, a very good fillet, as you can see here is no. But I just took this example of PTH. You can see here that a good fillet was formed, because you have to have a very good surface cleaning, so that the filler will be facilitate wetting on the joint and the pad, because this is the pad, right? If the pad is not cleaned properly, so they will not actually forming a good joint between the solder from the pin and the pad. So it's a very general. If let's say the question you said, what is requirement to have a good solder? So definitely you must have a clean surface. So when you can see here that the solder form like this is actually a fillet, but you cannot see clearly. So when the solder is actually forming a good, there has a category. When you refer to IPC 610, they have a category of this is good fillet, this is actually underfill. So there are a lot of categories, but to ensure all these happen, you must ensure that the areas of the PTH, for example, here for waste soldering, so you must ensure that the flood also have a pattern. So you must ensure that the flood was sprayed all over the boards, so that when the board go through the heater, when the heater heat the flux will be actually dissolve all the oxide and actually facilitate the wetting. So when the board travel to the with soldering, so the solder will actually easily touching the pad and form a connection between the pad and the pin. And it's, let's say, for materials or SMT, you have a chip or you have a IC. So the IC has a lid. So the lid is actually copper that coated with the solder. So what happened here during the process of reflow? So you have a solder paste. Inside the solder paste, you will have a flux. So the temperature profile for the reflow soldering have to set by the process engineer, by the technician, and verified by the process engineer. What they have to do, they have to ensure that the temperature is not shoot too high, so that the yeah, the flood will be combined in the solder paste. It's already inside the solder paste. So they have a metal powder, and they also have the flux inside the solder paste. That one is for the reflow, for the SMT component like chip, like IC. But for hand solder, the wire, there is no flux. Same as welding. So the wire doesn't have flux. So you have to apply the flux before you do a process of repairing. But for the case of wave soldering also, the bar, or nowadays they're not using a bar because the bar has a lot of weight. So what they do now, they are using a wire feeding to the bars, to the panggil bars lah, or wave solder bars. So before the board travel to the wheel solder, they will have another machines that will spray the flux first. So when the they will call that as a fixture, because the board have to fix on the fixture. So the fixture will travel and there will be a heater. So the heater will heat the flux. So then the flux will actually before they evaporate, they will clean and dissolve all the contaminants and then evaporate. Then after that, the board will travel at the molten of the bars. And when the board travel there, so the solder will be easily facilitate the wetting process because it's already clean. So there will be um, a solder that stick on the pad of the component and also the on the pin of the on the pin of your components. They're forming a joint. So they have a category. I don't have the RPC with me to show you that this is a good fillet. This is actually a bad fillet. So they have a category. But when they do a setting, a good setting, so definitely we will get a good joining. But for solder, they have to take out from because normally for solder paste, dia akan store dalam fridge. So dia kena bawa keluar fridge tu beberapa jam awal. Kalau dia keluar lambat, so you have moisture that entrap in your solder paste. So masa proses of reflow, you akan dapat void sebab you punya moisture tadi entrap dalam you punya solder. So there is a lot of defect that will be encountered, and we also can have a good joint. There are many factors. Selain daripada profile tadi, you akan guna juga stencil dalam untuk solder lah. You kena make sure that solder paste yang deposit on the pad tadi enough to have a form of volume. Kalau tak cukup volume solder paste that printed on the pad, kalau you printed sedikit solder paste, so macam mana dia nak form a good joint? So it's a lot of factors that actually influence the formations of a good solder joint. Boleh faham ke tak? Alright, so I have actually, but I'm going to give you on Thursday. we will have another homework on brazing and soldering. So I will actually write the details at the e-learn. So if let's say you don't understand, I will explain during class on Thursday. And we will finish on Thursday on the mechanical assembly. So on Thursday, we will actually complete the joining process on the mechanical assembly. So now you are already in final year. So you have to make up your mind where you want to work. So try to find out your interests. So if let's say you are interested in working in electronics, so find a what type of electronic company that you're going to work. Or if let's say you were interested to join to work in metal industry, or you want to become a welding inspector. So find a way how you're going to be success in welding. You might need a certificate for to be a welder inspector, or you are keen to become NDT inspector. So find a route where you can learn to become NDT inspector. So find a way. So now it's already time for you to focus on your career, even though you are not yet end of your final year, but try to find out what you want to be later so that you know what to do, what you want to focus on. If you want to be an NDT engineer, so try to find. And it will be good if you combine NDT with the welding. So find a institution that you can actually take the certificate of welding. They will be at Sungai Buloh, PWI. NDT tu banyak, tapi kalau yang saya tahu kalau NDT Sirim ada, macam-macam ada. So you find a way. Okay? If you want to work in electronic, find a way. What type of electronic you nak pergi? Kalau you nak pergi dalam semiconductor industry, or you want to go for the subcontract manufacturing, as I mentioned just now. So try to focus yourself to what you want to be. Okay? Because it's already 10 o'clock now. So thank you very much. So see you on Thursday, same time. So alright. So those yang tak makan lagi boleh makan. Okay, thank you. Bye.